Welcome, deer hunters, managers, and enthusiasts. This is Deer University, the podcast of the Mississippi State University Deer Lab. My name is Bronson Strickland.
And I'm Steve Damaris. Bronson and I are professors of wildlife management and co-directors of the MSU Deer Lab. Together, we've researched deer across the United States for more than 40 years. In our podcasts, we explain the why and how of deer management based on science. Whether it's research we've conducted or explaining research done elsewhere, we'll offer you a college course in the science of deer management.
But don't let Steve scare you. This isn't going to be a review of calculus or chemistry. Instead, we take results of research, reduce it to what's important, and explain how you can apply research to management. So join us for this episode of Deer University. Welcome back to our next episode of Deer University. Today we have back with us Dr. Marcus Lashley, who was with us a few weeks ago. You met with the listeners the first time, Marcus, and talked about your PhD program in North Carolina and coyote predation on fawns and habitat management and things like that. And we are going to continue that theme today and talk a little bit more about habitat, since you're a habitat management specialist.
Yep.
Marcus, this is a really, really cool story from my dorky perspective, because this is very similar to my life in that when I was younger and when I hunted, I always had questions. I always tell people I'm doing what I had to do because I never could turn it off. I'd be in the woods, be hunting, have questions about deer management, deer biology. And I was lucky enough to pursue a career where I could do that for a living. And the story you're going to tell us today is that same thing. So tell us about what you did several years ago, I guess, back on your land in Alabama. Tell us how you came across this.
Yeah, so several years back, just like you said, I can't turn it off. And I sit in the tree stand wondering, what is the deer doing? Why did it eat that? Why is it going there? What plant is it grabbing? How did it know to go and eat that one leaf in the middle of a whole bunch of other plants? It selects one leaf off of one species and then ignores the rest. So because of that, I've done exactly what you do. I sit on the tree stand and think about research and how I can figure out what is that deer thinking and what is it trying to do. And I stumbled across this interesting phenomenon when I started cutting down trees, and I didn't have any herbicides, so I'm just cutting them down with chainsaws around my tree stands, just opening up shooting lanes. And I noticed that it doesn't seem to matter what the species is. If it's a hardwood and it resprouts vigorously, the deer love it. So that's what stimulated this project, and now that I've gotten on faculty and I'm here in the Deer Lab at Mississippi State, I finally had the opportunity to go out and try to test what is going on with these plants. Why do deer seem to like them so much?
So you were going out originally, you were just cutting trees down. It wasn't really for a forestry management perspective. A lot of this was just like shooting lanes and things like that.
Sure. So, I'm hunting in Alabama primarily, where my family's land is. And, I put up a tree stand and then I look around to see, okay, where is a deer going to come from? I go through the natural process that most bow hunters go through. And I would see a mid-story tree here and a mid-story tree there that they're not doing anything but blocking my shot. So I just take a chainsaw in with me, I put up a new tree stand, and I cut down those couple of trees, to open up a couple of nice shooting lanes. And when I go back, being a habitat specialist, I can't help but notice what's going on and what's starting to happen when I do that.
You're also a plant specialist,
at
least relative to me. You're a lot more. But what's going on with that stump?
So, just to reiterate that, folks that I work with in the deer world think of me as a plant ecologist. People that are plant ecologists think of me as a deer guy. So I'm kind of caught in the middle on that one. And
you're a deer guy that knows a lot about plants.
Well, yeah, that's probably a good way to put it. So Yeah, so I'm constantly walking around in the woods thinking about what is a deer eating. That's just, I grew up doing that. I love it. And basically, when I started noticing these stump sprouts, they're regenerating that tissue. And if you think about that from a plant ecology perspective, essentially what you've done is remove the entire biomass of that plant above ground. So if we have a nice elaborate root system below ground and you remove all the biomass above ground, you've now mismatched biomass in that plant. So generally plants are somewhere in the neighborhood of 1-to-1 ratio in biomass of roots versus the leaf biomass above ground. So it's normally about a 1-to-1.
When you say biomass, tissue,
yeah, we're talking about
root tissue below ground.
The root system weigh versus how much does the above ground stem and leaves and everything weigh.
And on the average, that's pretty balanced.
Yeah, it varies by species, but they have a general range that they stay in, and there's some things that affect it in the environment, but generally there's a pretty close 1-to-1 ratio in most species, or somewhere in that neighborhood.
So let me qualify something. When you said hardwoods, that we generically in the South anyway, it's either pine or it's hardwood.
Yeah.
More technically, I'm going to try to act like a plant expert here, but we would call that a deciduous tree,
Yes.
Meaning that part of the year it's dormant.
Mm-hmm.
Part of the year it is actively growing, it has produced new leaves, conducting photosynthesis, etc.
Yep.
So when you were prepping for your bow stand, you weren't going in there in February. You were going in there when the tree was in the non-dormant season, when it was actively growing. So when you cut that stem or you cut that tree down, the tree responded immediately because it's still in the growing season. Yeah. That's why it kept resprouting.
Exactly. So the plant has, a deciduous plant has leaves through the growing season, and it's using those to photosynthesize. And then in the winter, they fall off, and the tree is dormant, like you said. And when you cut that stem off during the summer, when it's trying to photosynthesize, the reaction in the plant is called a tolerance reaction, and basically it's just tolerated a huge disturbance to itself. And the reason it's called tolerance is because of the way that the plant handles that. It handles it by basically converting all energy into growth. You need, if you're a tree and the number one resource you're trying to get to is light, and you just became much shorter, your number one mission is to grow tall fast. Mm-hmm. So that's what the plant is doing.
Grow towards the sunlight.
Yes, you're trying to get back into your canopy position as fast as you can, because sunlight is the lifeline for these things. I mean, they need water and nutrients, but they can't live without sunlight either.
Yeah, that's part of photosynthesis.
Yep.
Light.
Yep.
Okay, so you had this observation, and it started being very reliable. Yes. So you're tucking it away in the back of your head.
Yeah, I've been thinking about this for years, and I have seen it on countless species all over the place.
Now, when you got me on this, Marcus, you probably don't remember, but we were in the field one day, and it was actually green ash. Mm-hmm. And this is what was remarkable. This was when I was like, man, number one, this is really, really cool. Number two, I can't believe I've never noticed it before. But within eyesight, because we were kicking them with our feet and pointing to them, there were no less than 10, 15, 20, who knows, when you're in a green ash area. Yeah. There were all these green ash seedlings that sprouted from seed. The normal way. Seed hit the soil contact, it sprouted. Deer didn't touch them.
Yeah, they don't really like that.
But among all those seedlings was a stump, a green ash stump, where it had been cut down. And the deer were wearing out all of the new growth.
Yeah, and I do remember that. And the interesting thing about that situation is above ground, when we're looking at the green ash seedling versus the green ash mineral stump, they have about the same amount of biomass available to the deer. But the deer will walk around and eat the mineral stump and will completely ignore all those seedlings, because green ash is poor quality. It's not a highly desirable plant for them to eat. I mean, they'll eat it. don't get me wrong, deer will eat
If
just
they
about
have to.
anything, but yeah, they have to be in a situation where they're hurting for things to eat when they start eating green ash.
Right, right. Okay, so you've noticed this phenomenon for years and years, and from place to place you've been to. So this has been consistent from Alabama, Mississippi, you're working Tennessee, you're working
Tennessee.
North Carolina, and everywhere in between.
Florida, yeah,
So now you get into a situation where you can say, why?
exactly.
So now you can go to the lab.
Now I've been like when I got these results back, I was like a little school child again.
Mm-hmm.
I mean, I'm my maniacal laugh, in the lab looking at my computer, because I have literally been ruminating and dreaming about this for years, waiting to see if I can figure out what's going on.
And the results could not have been more clear.
That is correct. I was absolutely shocked.
You knew it was good. I mean, I think you suspected what the relationship was.
Yeah.
I don't think you suspected how overwhelming the results would be.
I did not expect the magnitude of change to be so great.
So let everybody know, what did you see when you analyzed those tissues
Yeah.
from stump sprouts?
So, all right, I want to reiterate what's going on in the plant again. So we have a huge root system that we have cut the tree biomass above ground off of, and now it's vigorously regrowing those stump sprouts, and it doesn't have that much leaf tissue. So that plant has to upregulate the nutrients in the leaves. And what I'm talking about is it's mobilizing nutrients within that plant. Okay? And it has to have a balance above ground and below ground. So if you take 10,000 leaves and make that balance, you don't have to put much nutrient in each leaf. But if you have maybe 100 leaves and you have to put the same amount of nutrients in those, now you have to super concentrate those nutrients in the leaves. And that's exactly what the results showed. Any nutrient that is mobile in the plant, which are things like phosphorus, potassium, a lot of the nutrients we think of as being really important to deer, they get upregulated in that process, and they get super concentrated in the tissues that are all available to the deer. And when I'm talking about upregulating, I'm talking about a 4 to 5 fold increase. So the leaf off of a plant, if you took a leaf off of a tree before you cut it down, and then you cut that thing down and let it resprout, and then take a leaf off of the new tree from that mineral stump, it's going to have 4 to 5 times as much nutrient density in that plant leaf.
And so another, I think explaining it the same way you did, just maybe a different way. That didn't make sense at all, did it, Marcus?
No.
Explain it the same way, but a different way.
Yeah.
You explained it in terms of leaves. If you had to distribute those nutrients over 10,000 leaves, let's just say, and you had 100 leaves. If you were to go now beneath the soil, let's just say, because of that below ground biomass, this may be an absurd number, but let's say that tree needs to upregulate, it's got to move 10 pounds, 1 pound, whatever, of this nutrient, let's say phosphorus. And so if it's got to move a pound of phosphorus from the soil and put it into leaves, if it's going to spread it over 10,000 leaves, then that nutrient is going to be it's going to be not very dense.
Yeah, very low concentration.
Very low concentration, very sparse.
Yeah,
but
so
you
each
can see
individual leaf is pretty poor in that,
Yeah.
and a lot of our tree species because of that.
But if you got to put that pound into 100 leaves, then the concentration has to
Yeah.
go up. Okay.
Yeah, that's what I'm using a technical term, upregulation, but that's exactly what it's doing.
It's trying to balance.
Yeah, it's just there's a balance in the plant, and remember, normally that's about a 1-to-1 biomass ratio, and if you cut that tree down, and now we have a 10-to-1 root to shoot ratio, it has to upregulate nutrients, maybe not necessarily tenfold in that case, but it certainly has to make them more dense in the tissue.
Okay. What did the data say?
It said precisely that.
Okay.
So we took red maples for this study, and I thought that was a perfect plant species because it's just like that green ash. We know deer will eat it, but they normally aren't eating it unless they're hurting. Mm-hmm. So y'all talked about it in the last podcast, I believe. Red maple is one of those foods in some areas, especially if you have really poor soils and there aren't a lot of good things on the landscape to eat, then it may be a selected forage, and I use that term loosely because it's just being selected because there's nothing else good available.
It's all relative.
Yeah, so selection is relative, and that's why I'm using that instead of preference. But, if there was something else available, even in that poor soil that was high quality, they wouldn't eat the red maple then. But in this case, if you create a mineral stump out of the red maple, you take that poor quality plant and you make it upregulate those nutrients and super concentrate them in the tissues, and now it is the highest quality plant on the landscape.
How does it compare with forbs? Forbs, broadleaf plants. And
y'all talked
Steve and I talked about that in the last episode.
You talked about it in the last one, and I was thinking, about this project because I was just getting the data in when y'all were talking about that, and I listened to that podcast and I was thinking about how does it compare to forbs. So I actually went, because of y'all's podcast, back to data. Now I've collected nutrient data on hundreds of plant species all over the place. I've always been a plant guy, and I've always been fascinated with what deer eat and why. So I literally, as a part of every research project that I've ever conducted, I've looked at the nutrients in all these plants. So what I did is went back to that database of hundreds of different plant species, and I was like, okay, what does the average forb look like on the landscape? And then I thought, you know what? No, I'm not going to look at it that way. What is the average content of forbs that deer love no matter where they're at? That's the comparison you want. Mm-hmm. So now we're talking about the highest quality plants on the landscape, not just the average forb, the average deer forb.
Highly preferred.
Yes. Mm-hmm. No matter where you go, the things that they always are eating. So we're talking about beggar's lice and pokeweed, things like that. No matter where you go, they're always highly selected. So I wanted to make that comparison to see, if this is going to be a new technique, then it needs to compare to the highest quality things on the landscape. So how better to measure that than to take some the forbs that deer love to eat that we commonly as biologists talk about being the ice cream plants, the most important things on the landscape for you to manage for because they're so important and nutritious for your deer. Mm-hmm. How does this compare to those? So in terms of crude protein, I was shocked about it, but I didn't get excited about it. We upregulated protein so that it was about the same as the average deer forb. So
why were you not excited about that? You took a red maple, the resprouting of a red maple tree, and gave it the same.
It's a terrible quality plant,
Yeah.
Deer, they just ignore it on the landscape normally if there's anything good. If you're managing your forest well, they're ignoring red maple. So
you were getting 17, 18% crude protein from this red maple stump.
Yeah, that was the average. Now I cut a range of different sizes, and some of the bigger stumps, I had a couple, 3 or 4 of these things out of 100 that were 30% crude protein.
That's soybean crude protein there.
Yeah, we're talking about blowing the wheels off of it. Mm-hmm. We're talking about a 4-fold increase in protein in that plant, and that didn't get me excited.
You're a hard man to get excited. So
if you already are managing for forbs that are all the same quality, then what's the point? You already have high quality forbs on the landscape. So to me, that's interesting, but it's not game changing.
All right. Well, lay it on us. What was the game changer?
Well, I like to focus on phosphorus because it's so important in antler growth and lactation, and it's something that's commonly limiting. So we think about protein being so important, but normally that's not limiting in the landscape. What's limiting commonly, or more commonly at least, is phosphorus. And not only did we upregulate phosphorus in those leaves to the same as forbs, we actually doubled it. So the average forb, the high quality thing, the best thing on the landscape, we took the poor plant that deer don't like and upregulated that nutrient to double what it would be in the forbs. And I also thought, you know what? Okay, we're talking about native forbs, right? What about food plots? They've got to be there. They've got to be the same. Nope, doubles those too. So I'm talking about soybeans and cowpeas and lab, all those things, deer vetch. Those are all forbs. We're planting them in our food plot, trying to enhance nutrition. And here we've taken a common red maple, that thing that nobody thinks about being important, and we have upregulated the nutrient to be twice as good as even the things that we plant in the food plot.
So you're getting the same amount, just about anyway, the same amount of crude protein, but double the amount of phosphorus as well as some other nutrients.
And about 10 different nutrients. So everything that's mobile in the plant. And I know that doesn't mean much to a lot of people. And it means some to me and a lot more to a plant ecologist. But basically, some of the plants accumulate over time in tissues as plants are going through their processes. And other things accumulate in different parts of the plant, and then it mobilizes it to different places to store it. So not all nutrients move in the plant to be stored somewhere other than where they're produced. But phosphorus and potassium and a couple, there's 8 or 10 other nutrients, they're actually produced in a lot of places in the plant or absorbed from the soil or whatever, and they're mobilized to be stored in leaves.
Okay. So you've got a stump sprout from a medium quality to low quality that is exceeding in every way. It's equal amounts of crude protein and
so this is why
3 to 4 times the amount of minerals.
This is why I got so excited about it. So we brought it up to par, just average on crude protein. It's really high, don't get me wrong, but it's comparable to the other high quality plants on the landscape in protein. So we're delivering that to them with them eating it. But now we have essentially made the nutrients so densely concentrated that they don't have to eat that much to get the same amount of nutrients out of it. And when we can deliver that same crude protein and that super dense nutrient load, that's what got me excited, because there's nothing else in terms of plants on the landscape that are comparable. And again, we're talking about red maple. This isn't a high quality plant. It's not a highly selected forage. But if you make it a mineral stump, it is the best thing on the landscape, and deer will show you that because they will absolutely go crazy over that thing. It became the high selected plant on the landscape. Now let me just give you an example of how much it changed. So my student Don Chance is working on this site where we did this mineral stump idea. And he, just as part of his research, everything I do has plants involved. As part of his research, he was actually looking at regular old red maple seedlings that are in the reach of deer as part of his broader plant community survey. And when we were walking around, if we actually counted the percent of red maple seedlings that are browsed, it's less than 5%, and somewhere in the 2 to 3% range. If you make a mineral stump out of that red maple, that goes to 100% browse.
Every single one of them.
Every one.
Marcus, you've said it a few times. I don't know if we've defined it yet, though.
Yeah.
You and I, joking around, kind of started using this term.
Yeah.
You're calling it a mineral stump.
Yeah, that's what I'm calling it. I'm calling it a mineral stump because of this upregulation process. So this is a really simple habitat management technique that you can use to upregulate that tissue. And you're fortifying it with nutrients, which is essentially the same thing you would be doing if you pour minerals out on the ground. Except now we're doing it with vegetation that deer are designed, they're designed to eat it.
The minerals are coming in the format from which they are evolved to eat it. And
their entire body is designed to get nutrients out of leaf tissue.
From vegetation.
Yeah.
Yep.
And I've thought about this quite a bit, and one of the roles I play here at the university, as you know, is a disturbance ecologist. So that's just a fancy term for meaning I study how plants respond in terms of habitat to disturbances like fire and silviculture, cutting down trees, thinning, that sort of thing. That's my job here. And I couldn't believe it when I saw this upregulation of nutrients. And it all makes sense when you start putting it in terms of disturbance ecology. So the entire...
Well, to someone that's not a disturbance ecologist,
Yeah.
tell me how it makes sense.
Yeah, it makes perfect sense. So you think about how deer are designed. Why would they be focusing on these stump sprouts? It seems like they knew what was going on. They don't care what the species is, but they somehow know if it's a stump sprout, I need to eat that because it's super fortified, right? But how does the deer know that? And then I started thinking about, well, what ecologically, was there anything that mimicked this in the historical, habitat for deer? And I thought, you know what? Fire was so prevalent, or windstorms, or things that top kill trees. And in fact, these trees resprout because their adaptations are focused on being able to regenerate after disturbances like fire. So a red maple, that is a mechanism for it to not be wiped out when a fire occurs.
And it's the deer's adaptation to capitalize on that.
So that's one of the reasons that we have dramatically, in my opinion, underestimated how important fire is.
Yeah.
Because we don't, normally in a study what we would do is measure the leaf tissue from red maple seedlings somewhere and then apply that to our treatment that's fire. But if we created all these mineral stumps in that fire stand, we wouldn't have noted that we had this huge upregulation of nutrients, which actually would increase carrying capacity following that fire for deer dramatically. So we have very much underestimated, I think, based on this data. And just to give you an example, Don and I went back to his data, and he actually was keeping up with whether or not plants after fire treatments were stump sprouts or not. Without even taking into consideration the nutrients, we would have thrown those out. So if we add those back into the biomass that we're calculating carrying capacity with, we would have increased it an order of magnitude just by adding that back in.
10 times the increase.
Yeah. And then you talk about a 4 to 5 times the nutrient composition.
Yeah.
So that's running away with carrying capacity now. So it makes a lot of sense when you start thinking about it from a historical perspective and how prevalent fire and windstorms, hurricanes, tornadoes, all those things that are breaking trees off, and the reason that they stump sprout is an adaptation to deal with that frequent disturbance. So something like a pine, it has really thick bark. Its strategy to deal with fire is to buffer itself from it so that it doesn't get top killed. Well, hardwoods took a different approach, a lot of them did, and their approach is, I know it's going to top kill me, but I'm going to tolerate that and grow as fast as I can to get back to my position.
I'm going to bounce back quickly.
And deer, because of this extreme nutrient loading, have adapted to deal with that and take advantage of it when it happens.
So 2 things, Marcus, come to mind in the relative to deer management and deer habitat management. So I want, if you don't mind, to address both of these. One thing that's been around for a long time is hack and squirt, and we've done it right here hundreds and thousands of times.
Advocated it over and over again to landowners I've worked with.
So with that, you are hacking the bark, you're cutting into the tissue of the tree, and then you're applying an herbicide. That's the squirt part from a squirt bottle. The other that we see all the time is becoming more and more popular is hinge cutting.
Yep.
So why don't we start with that? Let's start with hinge cutting.
Yeah.
So what would be different between creating a mineral stump and hinge cutting? What things might they have in common and what things might be different?
Yeah, so they have some common goals. One thing is you're letting sunlight to the ground, so it doesn't have anything to do with that tree, and that's good. I'm not saying forbs are bad in any way. Getting light to the ground is a good thing. So they both accomplish that goal. But the purpose of hinge cutting is to cut partially through the tree and lay it over, and it's not as much for food. So those leaves are available. In some species, they absolutely will eat all of the leaves that they can reach on it, like black gum. If you do it with black gum, they're going to eat the leaves off of black gum because they love black gum. But what I see the benefit of hinge cutting, the real benefit is that the tree continues to live, and now you have living cover.
Mm-hmm.
So the deer are using it for cover, and I think that's the real important thing. What you're not going to see is that incredible upregulation of nutrients, because you didn't change the biomass ratio. We didn't change with hinge cutting how much biomass was above ground. We just changed whether or not it was in reach of deer. That's all you changed. So if you lop that tree off, many hardwood species are adapted to respond by stump sprouting, and it turns it into a mineral stump, which now upregulates that nutrient because of that ratio and makes it the highest quality plant for a deer to eat. No matter what the species is, it should work with anything because of that plant ecology.
So hinge cutting, different purpose. We're doing it primarily for cover, and if we get some good browse to go along with it, fantastic, but that's more a function of, was that tree species a preferred tree species? And you're not really going to fundamentally change the concentration of nutrients in a hinge cut.
It's
tree.
definitely not going to upregulate. It may upregulate it to some degree because it's been injured, and it may respond to that by increasing it, but you will not get the same fortification of nutrients that you get in a mineral stump. You got to think of these plants, this has been going on a long time. This hasn't just been since we invented a chainsaw. Fire and wind storms, wind has been hinge cutting trees for a long time. And fire has been creating mineral stumps for a long time. So we're just now taking a really simple technique that we can apply with a chainsaw that mimics those processes, and they both could be really important. Another similarity that some people may not realize between the two is now you have a nice little obstruction. So you have a stem that you've cut down in a mineral stump, or you've laid over with a hinge cut, and you can start directing deer around your stands with those things. They're not going to walk over a tree that you've laid over. They're going to walk around it.
So use it to your advantage.
Yeah, absolutely. I do this all the time.
Yeah. So what, Marcus, is, we talked about hinge cutting, now let's talk about hack and squirt.
Yeah.
So the difference now with hack and squirt is that you kind of originally, you had a similar purpose in mind, that I want to take this tree, I want to get it out of the mid-story, I want to get sunlight on the ground to produce food and cover for deer, but now you've killed the entire tree. You've killed the above-ground biomass as well as the below-ground biomass, so you get no benefit from mineral stumping.
You don't get the mineral stump benefit.
Yeah.
That doesn't mean you don't get a benefit. So, there are a couple of things that are going on. One is, at a large scale, sometimes hardwood encroachment is something you're trying to deal with, especially if you're in the lower coastal plain. That typically is degrading habitat. We use frequent fire a lot, and you may have to use herbicides and even hack and squirt. So you could get benefit in that way. The other thing, and the intent of hack and squirt generally, is to kill that tree to let light to the ground. So you can still get benefit from that. I'm not saying at all that that's not a good practice. I'm just saying you're losing the mineral stump out of it, which you can basically localize factories of nutrient production with that mineral stump. And what better way to enhance a mid-bow season stand than to provide extremely high quality nutrient fortified tissue. So you're losing that by killing that tree, but you're still gaining from that practice by letting sunlight go to the ground, which is the reason that it's been pushed.
Yeah.
It's a timber stand improvement practice that can be very important and very useful for your deer management.
So, let's reiterate that, Marcus. We're not in any way, shape, or form saying to not use that tool of hack and squirt, nor are we saying in the South or wherever you shouldn't hinge cut. All we're saying is now that if you completely fell the tree, you cut it completely down and allow this mineral stumping process, it's another tool
Yeah.
in the toolbox for you. And if you're strategic about it, you know, you've got it from a nutrition standpoint where you want to put these on the landscape. Again, just diet quality and adding minerals to the diet. But if you're bow hunters like us, you can do this strategically.
Oh, yeah.
Where I'm going to do it about 100 yards away maybe from a food plot and...
Yeah, or 100 yards from cover. Maybe ideally 100 yards between cover and a food plot.
Yeah. Or maybe now you make a mineral stump corridor
Yeah.
all the way to a food plot.
Come on now.
Yeah, we got to get out and do that.
Yeah. You're making bow hunting too easy.
Let's wrap up then, Marcus, with management recommendations, which we were kind of just talking about. Let's think about scale. So, and we've got a lot more research. In fact, we got some projects coming up. We're just at the tip of the iceberg
stuff going right now
here with this. What are you thinking in terms of on a property scale? If you're really going to be increasing or improving diet quality, you got to do this a lot. This isn't just...
Yeah.
There's a good example right there, Marcus, of if you're doing it for hunting, you know, you may only do this 3 or 4 or 5 times, and you've created a great little interception point to catch a deer, you know, for a bow shot. But if you're doing this on the landscape to improve diet quality, you're doing this hundreds of times.
Yeah, so just to put it into perspective, we don't, like you said, we have ongoing projects and we haven't ironed out some of these things. I think this could be a really important practice, so I'm following up with a lot of research so that we can really make this a good tool for the average hunter or land manager. And with that caveat, now I want to go back to Don's data for a minute. So we didn't have this project designed to measure how much biomass we were producing. But obviously when we went back and looked at it, it was quite a lot. So we know that it's this, one stump, it can be defoliated over and over, and because it has so much reserve in that root system, it just continues to produce more leaves. So I went back and calculated, based on some rough data, how many 5-inch red maples would we have needed to equal a soybean acre plot. And what I came up with was about 100. So I don't know if that's accurate. Again, there's going to be a lot more research to figure this out, but that's pretty easy to do.
If you said this and I missed it, Marcus, I apologize. What's the average size? We use the term, we all have forestry in our background here, but we use the term DBH, diameter at breast height.
Yeah.
But that's basically the diameter
the size of the tree.
The size of the tree. So give people some perspective about, on average, how big are these trees that you're cutting down? How big are they? Diameter.
5 or 6 inch diameter.
All right.
And that's at your breast height.
Okay. So it doesn't have to be a bunch of gargantuan
trees. And one of the things that we were interested in is, does it matter what size of tree you cut down? Mm-hmm. And the short answer to that is yes.
It sure does.
It makes a lot of difference. You remember the one I was talking about, 30% crude protein, or the few of them? Those are like 12, 13, 14-inch maples. So the bigger the tree you cut down, the more you get out of it. It produces more biomass. But think about what you're doing again. From the plant ecology standpoint, you've mismatched to a greater degree the root to shoot ratio.
You got so much more root biomass that now you have to stabilize all that.
It had to be a much more developed root system on that bigger tree. So the bigger you cut down, as long as you don't reach a critical point where it no longer will stump sprout, which some hardwoods get to a critical size and they no longer will stump sprout. But as long as you stay under that and you start getting the stump sprouting, you're just going to increase the benefit of it.
What's the duration, Marcus, that you've seen? You gave me one example. You've had one stump sprout, one mineral stump going for 4 years now.
Yeah.
Do you think that's the average, or think?
This is another question that we're looking at in the research that's ongoing. I don't know. Okay. I don't know why some of them die after one season and some go on for years. But yes, you're right. We've had a few different examples that last at least 4 growing seasons. And the interesting thing about that is deer like them so much, we're cutting these things down, and deer are essentially a pair of pruning shears. Mm-hmm. They keep coming back and eating it over and over again, and the thing stays knee height. Mm-hmm. And for years.
Yeah.
They trap it in the understory where it never gets out of their reach.
Just looks like a shrub.
They just come back. I wish they would do that to the shrubs in my yard, because I'm about tired of clipping them.
Yeah.
I have to do it all the time. I wish the deer would come and do that for me, because some of these mineral stumps in the woods are the most perfectly formed bush that you've ever seen. And they're knee tall or maybe a little bit taller, but the deer just keep coming back to them over and over. And some of them last for years, and some of them die the first growing season. I don't think we had any that died before bow season. And we're cutting them down primarily in June for this research. So we're talking about midsummer. The reason we targeted that is because you get this huge upregulation of nutrients when it first starts resprouting, which happens to coincide perfectly with peak lactation and peak antler growth. So that's why we chose that timing. And again, the timing's pretty important, because you want that tree to be actively growing when you cut it down.
Well, Marcus, home run, brother. Absolute home run.
Very excited about it. It's nice to have something you've been talking about and thinking about for so long come to fruition. Mm-hmm. So I'm really glad, and I hope this helps all our listeners with their deer management and their hunting experience, because it's already helping mine, and I'm very excited about it.
Well, Marcus, you put together a short video for people that are going to get to this podcast from Facebook. They've already seen your video, mm-hmm. but we'll try to get that posted in other places as well. But you got a great 5 or 6 minute video with mm-hmm. pictures. Pictures is always worth 1,000 words.
We've even got a video showing a deer responding to our mineral stumps.
Yeah. So, and you and I have already been thinking about all the stuff we're going to do subsequent to this, experiments.
Yeah, we've got some experiments planned. Also, think it would be good, and certainly we'll take comments from the audience if they have things that they'd like us to do. But one thing I really want to do is a how-to video, and let's get out in the field and cut some stuff down and create some mineral stumps and show people strategically how we're doing it.
You know what month it is, Marcus, right now?
Yeah.
It's June.
Yeah, it's the month to do it.
We got to get out there here pretty soon and get it done.
Yeah, I'm thinking next week.
Okay.
I've got a chainsaw with me, actually, so we can
I do too. Yeah. All right, Marcus, anything else?
I think that's all. I really appreciate the attention of the listeners, and very excited about this, and I hope everybody else is too.
Well, we hope it is a new technique, creating mineral stumps on the landscape for nutrition, to improve diet quality, and also to create some really strategic hunting opportunities coming up this fall. So by the time this podcast goes out, there's going to be time for people to get on the landscape, create some mineral stumps, and get some venison in the freezer because of it.
Put a chainsaw in your truck and cut down some trees when you're in the woods.
And also in the interim, if you don't believe this, put a camera on it.
Yeah.
Get the photos of the deer using it.
Cut one down and put a camera on it. And put it on video. Yeah. Because there's nothing more satisfying than watching a nice, mature buck devour a mineral stump.
Absolutely. Well, Marcus, thanks a bunch. We'll say goodbye for now. Mm-hmm. And as soon as we get more data from this project, we'll come back and do another podcast here in a few weeks or a few months.
Mm-hmm. Sounds good to me.
All right. Thanks, everyone. We'll see you next time on Deer University. We're glad you joined us today and hope you learned something valuable about deer management. If you have questions about this podcast or a question about a topic we haven't discussed, please log on to msudeerlab.com, click on the Deer University tab, and send us your questions. We'll get to them as soon as possible. In closing, we want to thank our employers, the Mississippi State University Extension Service and the Forest and Wildlife Research Center. We also want to thank the St. John and Dudley Hutchinson families for their endowments that support deer research and education.